All right, friends and neighbors. I had to do some emergency travel, so I wasn't able to get to all the Chapter 15 stuff, but I didn't want to leave you hanging. So we're going to do some Chapter 15 subnet design problems to keep us on our toes and to keep those subnetting juices flowing. So let's do a couple of scenarios. So the first one we're going to do is you have a company with 4 departments and an address space of 192.168.1.0/24. What subnetting scheme might be best? So we'll take a quick look at what a topology might look like after we're done with this. But if we just start with the basics, we might say, well, okay, this is actually a fairly straightforward problem. And so we go, well, this is 192.168.1.0. And what do we know about this address space? Well, we know that there are 256 possible addresses. And so if we said these subnets are going to be the exact same size, then I might say, well, 256 divided by 4 is equal to 64 nodes per subnet. All right, so that's pretty easy, pretty straightforward. I also know that there would be 62, right, usable. Usable, there we go. Because we need the subnet IDs and the subnet broadcasts. Now, if I was going to do this, sort of the quick and easy way, I might say, well, we're going to do equal size subnets, and I'm going to do just 4, and I'm always going to start with a classful address space, so I know that my first subnet is going to be 192.168.1.0. Well, if I have 64 possible, I know that we start counting at 0, so that means that the highest possible address in this range is 63. Okay, now if I just keep going, right, I go 192.168.1.64 would be the next subnet. If I add 63 to this and go 64 to 127. 127. So that would be my range there. And then I would go 192.168. Well, just add 1, right? 128. And we would go add 63. 192.168, 1.191. And 192.168, 1.192. And that would go 192.168, 1.255. So here we've got 0 all the way up to 255. We've done 64 nodes per subnet. Now, if I wanted to be, a little more clear about what we were doing, I would say, well, let's remember that the class full mask would be 255, 255, 255.0. But to create 4 subnets, we need to steal bits from the host portion. So how many bits would we need to steal for this so that we would learn our new mask? Well, we would have to steal 2 bits, which would give us a new mask of 255, 255, 255, 192. Well, there's a lot more questions that we might ask here. We might also say, what would be a router here? Right? What would be my router? Well, routers would be high in the range in a particular subnet or low in the range. I prefer high in the range, so I would pick a router that might be 192.168.1.62 here. And the router here, we'll go ahead and write it, router would be 192.168.1. Well, high in the range here will be 126. The router here would be 192.168.1.190. And the router here would be 192.168.1.2. 1.254. Okay, so these are what we've come to know about a really, really basic subnetting problem. But of course, we know that there is maybe a more, say, intellectual way of doing this. So let's take a look at that next, right? Well, we know that if I take a mask like this, then I know that when I look at the mask and I say 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and we'll do our spaces to make 2, 3, 4, 5, 6, 7, 8. 1. Well, so we'll start with this. I think that's 8. Okay. So this is the default mask, but what I'm going to do is steal those 2 bits. Well, how do I steal those 2 bits? Well, I turn them into 1s, right? That's how I do that. So that becomes the subnet field. Well, what are my 2-bit patterns? Well, those would be 0, 0, 0, 1, 1, 1, 0, and 1, 1. And so now we know that if I convert my address space into binary and then do those conversions, I can automatically get the patterns by putting all zeros in the host portion and all ones in the host portion. Now, after all, I'll just remind us about this, right? If I take my class full address space and I said, let's convert this to binary. So I go 128, 192, and then 1, 2, 3, 4, 5, 6, right? And then I go 168 is 128 plus 40, 64, 32, 16, 8, 1, 2, 3. Okay, and then 1, that one's pretty easy. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is my class full address space converted to binary. But we know that with the default mask, right, with our default mask, this is our host portion right here, right? So I get the class full address space because those host bits are all zeros. Well, what is the broadcast? What is the highest address? Well, it's 255. So my range, I'll make sure we don't get too crazy on the colors. My range, we'll copy this whole thing. Right? Would be putting all ones in the host portion. So that actually gives me my range of 192.168.1.0 to 192.168.1.255. Okay, so if we do the same exact thing with our subnet problem, then we can find out what the highest and lowest in the range will be. And so now we're going to take this pattern, right? Keep it all separate. Okay, we know that this is the class full address space, and we don't actually want all of this red at one point here. We know, because we stole 2 bits, that this is actually the subnet portion. What we're going to do is take these patterns and place them in our subnet field. So there's our subnet field. And maybe we don't have to muddy this up too much. Okay. So there is our subnet field right there. And our first pattern is 0, 0 in there, right? We're going to do 2 things here to help us out. Remember how to do this. We're going to say first, we start with the class full address space. And second, we're going to put all zeros in the host portion. Oops. Backspace here. We're going to put all zeros in the host portion, and then we're going to put all ones in the host portion. So this is 192.168.1. there's our subnet field value. And then we're going to put all zeros in the host portion. Well, what does this come out to be? Well, this is 192.168.1.0. Hey, look, it's starting at the classful address space. So now I'm going to come all the way over here. And when we put all ones in the host portion like this, well, what do we get? Well, that's 32 plus 16 plus 8 plus 4 plus 2 plus 1. This comes out to be 192.168.1.63. All right, so we're going to do this again, okay? But this time we're going to put the next binary pattern in there. Well, what does this come out to be? Well, the lowest address by putting all zeros in the host portion is 192.168.1. Well, what is this value right here? 1.64. And we come all the way over here and we say, well, 64 plus 63, 192.168, 1.127. So what I'm doing here is this, I'm looking at that pattern, and I add all these numbers up, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Our next pattern in our binary space is 10. Well, this value is 192.168, 1.128. And all the way over here, this comes out to be 192.168, 1.128 plus 63, 191. So now we're going to take our last binary pattern, 1, 1, 1, 1, and we're going to say, well, what's this? Well, this is 192.168, 1.192. So I'm just on autopilot at this point. I just remember a couple of rules. We start at the classful address space, and I'm just substituting in my binary. So 192.168, 1.255. So here we've got the highest in the classful range and the lowest in the classful range right there. Well, this is the lowest and this is the highest. So there was the classful network address. This was the classful broadcast address. Now these are the broadcast addresses at the subnets, and these are the subnet IDs, right? All ones in the host portion for the broadcast, and all zeros in the host portion for the network address. Okay, well, what would the topology look like for something like this? Well, we might have a couple of topologies, right? So I might have the addressing look like this. This might be 192.168, 1.0. We might have 192.168, 1.64 here. 192.168, 1.128, and 192.168, 1.192. Now, in the case of this network here, this network here, this interface might be 62. Now, the tricky part right here is we have two router interfaces. So here, I might have said, well, I wanted high in the range, right, 126, but I actually might do something like this because I have two routers. I might do something like that. Over here, 128 to 191, well, I might have 189 for my routers and 190. So 128 to 191, and here I can probably get away with just 192, 168, 1.254 or 253, whatever I wanted to use for my convention. So those would be high in the range. Now the topology could also be something like this here, where the 1.0 is here, 1.64 is here, 1.128, and 1.192. In which case, this might be 62 here. This might be 126 here, 190 right there, and 254 right there. So there are a number of topologies that might fit this particular subnetting scheme. Okay, let's take a look at the next one. All right, scenario 2, we have a company with 5 departments and an address space of 172.31.00/16. What subnetting scheme might be best? Now, again, we're gonna keep it simple right now. We're just gonna say, well, I've got this classful address space and all my subnets are gonna be the same size. Now, it might be very tempting to say, oh, that's easy. I'll do 5 subnets. So we want 5 subnets. So how many bits to steal? And so here's the trap. We know that subnets are a power of 2. Just like the host address space is a power of 2, the number of subnets that you create is based on a power of 2 because we're stealing bits. If we steal 1 bit, we create 2 subnets. If we steal 2 bits, we create 4 subnets. If we steal 3 bits, we created 8 subnets. So in this particular case, you cannot create 5 subnets. It has to be a power of 2. Now you could say, well, why can't we do 4? Well, if we want subnets for each department, then 4 subnets is not enough. So therefore, we're going to steal 3 bits. So the new mask, right, will be, let's see, the class full mask is 1, 2, 3, 4, 5, 6, 7, 8. That way, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The class full mask is this here. We are going to steal 3 bits right there. Whoops, right there. And we're going to do that by converting them, of course, to 1s. And so the new mask would be 255, 255, 224.0. So all the work is being done in the 3rd octet. Now, this is a full class B address space that we're talking about. So we could say, well, a full class B has 65,536 possible with 65,534 usable. Okay, so we say, okay, 65,536 divided by 8 is equal to 8,192 addresses. There we go, I'm good. Go ahead and figure out what your networks are. And this is where we find out that the binary is much, much easier. We break this out into binary, and we remember that the very first subnet is going to be the classful address space. We need 172. So we go 128, 160, 168, 172, like that. And then 31, well, that one's pretty easy. 128, 64, 32, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, this is the binary for the classful address space. But we know that this is the set of subnets, or the subnet bits. Now, what are our patterns that we're looking for? Bit patterns would be pretty straightforward. We're just counting by binary, right? So here's our 8 subnet sort of placeholders, and we're just going to go through these binary patterns right here. So I'm going to take this one and I'm going to say, well, let's make that a 1. Make that a 1, 0. That there. Hopefully you're following along with what I'm doing, but I'm just putting in the binary patterns. Well, what does this work out to be? Well, we know what it is. This is 172.31.0.0. Now, if I was doing the math and I was saying, okay, well, the range is, the possible is 8,192 per subnet. That would be 0 to 8,191. What's the binary for 8,191? Well, I could do that. I could do that. Or I could say, well, what if we figured out the broadcast address for this particular subnet here? Okay. Well, how would we do that? Well, we know how to do that. We would convert the host portion to all ones. And so I'm going to do that right now. Well, what does this work out to be? With 5 ones there, it turns out, miracles of miracles, this is 31.255. Now let's do a quick game here. We're going to pull up our programming calculator. And I'm going to select binary. And I'm going to put in there 13 ones, right? So I've got 8 here and then 5 more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Take a look at my decimal number there. 8,191. So that's just another sanity check that says that we're doing okay here. We know that the next subnet is just going to be one more than this. Now, I can look at this binary and say, well, what is this value? Oh, well, that's 172.31.32.0. Does that check out with adding 1 to this number? Well, it sure does. All right, so we can probably speed things along a little bit here. This is 172.31. This number right here is 64. Well, what do we think 64 is, or the highest in the range? Well, I could say this. Let's cheat a little bit, right? And then we'll check ourselves another way. This next network is 172.31.96.0. So now if I guess and I said, okay, I'm going to take this binary. Let's convert those the same way that we did before. Now, I know that if I look right here and I say, well, this is the 32 net. What's the broadcast at this next network? Well, I know that if I put all ones right there, I get the broadcast or the highest address. But another way to do that would be to look at the next subnet up and just go one less. So if I guess and I said, just going to guess, I'm going to say that the highest one in that range is going to be 172.31. 1 less than 64 is 63.255. Well, let's see if this actually works out. Well, if I take 32 plus 16 plus 8 plus 4 plus 2 plus 1, I get 63. And then I've got 8 ones here, 255. All right, very good. Now that we know that, I could say, oh, I look at this one and I go, I think this is going to be 172.95.255. And so this is 64 plus 31, so that's 95. All right, so we'll finish the subnets here, and then we'll fill in the rest. Okay, so this is pretty clear. It's 172.31.128.0. 172.31. Now this is 128 plus 32, or 160.0. 172.31.192.0. And this is 172.31.224.0. Now, a couple of things about this. We know that when you're doing your subnets, your subnet IDs, it'll be all zeros in the host portion. And this looks very clean. These look like Class C addresses, but they're not. The last octet just happens to be 0, but we have to remember that we've got these zeros here also. So our host space is actually much larger, right? It's 8,192 possible. All right, so what are our binary patterns here now? Well, the shortcut that we could take is that, right, if that 0 right there is 128, so if we have all ones, it's one less than 128, so it's just 127.255. Well, this is 128 plus 31, or 159.255. And here we have 128 plus 63, or 191.255. This is 192 plus 31, 223.255. And here we have 255.255. This one is easy to check because it should just be one less than the next subnet ID. This one here should be one less than that subnet ID. And this should be one less than that subnet ID. So here's another way to look at this, right? Here are our ranges. Now that we've done the binary, we'll just lay it all out here. And this looks fairly uniform now. But a really good question would be, all right, good. Now that we've got our ranges, we know that we got our subnet IDs by putting all zeros in the host portion. We got our broadcast by putting all ones in the host portion. What might a router be? Well, in this case, if we went high in the range, like I like to do, then we might do 172.31.254. So a router here might be 172.31.63.254. And you see a sort of pattern emerges because we have all this host space, 172.31.95.255. Now we also have to remember that these are good size host spaces and that each one of these routers would be handling connections for 8,192 possible, 8,192 or 90 usable addresses within the subnet space. So that's a lot of host addresses. 191, 255, 223, 250. Whoops. Whoa, what am I doing here? What's going on? Let's change these to 254s. There we go. Good gracious. Now this is a weird one, right? 255, 254, but there we go. It's just high in the range. Now with 8 subnets, this could be all over the place, right? I might say I've got all of these subnets sprinkled everywhere. And so what might the topology look like? Well, we'll do one example of what the topology might look like. Right, if I ignore all of these labels that I had here, and I just said, well, what would happen if I took this router and connected it down here? Well, how many subnets does that create for us? Well, 1, 2, 3, 4, 5, 6, 7, 8. So this could be all of my subnets. There's nothing wrong at all with, a mixed layout topology. Now I'll just add one more thought to this as we go here. You might find out that 8,190 possible or usable hosts in a subnet is an awful lot. So you might further subnet something like this. So you might take one of those subnets and change the mask for that one so that you could further subdivide it. So that's a totally legal approach to that. I think we'll do some variable length subnet masking later on in the course. But there we go. So that's an example of topology where you can mix star wire topologies and things that are very sort of linear. Well, there we go. That was some Chapter 15 subnet design practice. I didn't want to leave you hanging. A couple examples to keep you on your toes. There'll be more chapter details when I get back from traveling. Like and subscribe to increase your subnetting power. And whether you're creating an odd number of subnets or an even number of subnets, may those packets always reach their destinations. And remember, this is CCNA. You can do this.